While I'm waiting for the epoxy to set up on this IF transformer for my Sylvania project, I thought, well, maybe I'll make a video of this superior tube tester. We'll take it apart and see what's the matter with this pesky switch right here. She worked great for about 5 tubes and then just they kicked the bucket. So I don't think anybody has ever done anything to this. I think it's probably all original. So we got to take out about half a dozen screws. I took some of these out the other day. I was going to take this apart and I got doing something else. So let's go ahead and open it up and see what we got. And here's the inside of the superior tube tester. We got a nice big beefy transformer in the bottom there. It brings our power in off the line cord. Actually goes up to this power switch and the line voltage switch first, up here. And then it feeds it back down into the 120 volt side of this transformer. And it's got a couple primaries, secondaries and whatnot, center taps probably, filament voltages, all kinds of stuff that comes off of it. It's funny, this tag down in here says moisture resistant weld wood. This is a genuine weld wood plywood panel made with exacting care and fully guaranteed. While it is highly moisture resistant, it should be used only for interior purposes. For exterior use, waterproof weld wood should be specified for interior use. Interesting. We've only got one capacitor in this whole thing, which is right here. It's a 600 DC working volt, 0.02 microfarad. We got a few old dog bone resistors. Here's one. Here's some a little bit newer one up here. Over here we have a tiny little RCA branded tube of some kind. Interesting. I wonder what that is. I wonder if I can get that out of there. Be curious to know exactly what that little tube is. It's a tiny little bugger. It's RCA. And it says JRC 12H6 for a VT214. Never heard of such a thing. I believe it's metal. Interesting. A standard base like most RCA tubes did. 7 pins. Fits right in the back here. I wonder if that's like a rectifier tube or something like that. Fits right in there. No, right there. So while we have this apart, I think I might have the proper capacitor to replace that baby with. And I think to try it out, I'm going to use some deoxit on these switches. See if maybe with the intermittent connection we'll clean up a little bit with that. I'll spray some of these contacts. They're looking a little rough and oxidized. Just needs a little TLC. 1946, that's a long time. Well, here's where having a tube receiving manual comes in very handy. A 12H6, this is a twin diode, and it's basically 12.6 volts, of course, 0.15 amps. It's a voltage doubler, half-wave rectifier. Supply voltages to the plate, 117 volts, 30 ohms half wave, 15 ohms full wave, 150 volts across the plates, and 8 milliamps DC output across the plates. Interesting. 12H6. I'd never heard of one before. I don't know what the heck the JRC stands for on the side of that pup dog. I might have to look at one up online. So that's come in handy many, many times. Okay, let's see if we can finagle this capacitor out of here. Well, with our capacitor taken out right here, this jumper behind the tube leakage indicators right here on this side. Yeah, that was on the tube side. And it jumpered between here and the high-low filament switch right here. So we took it out. It's a .03 is what it is. A 600 working volts DC, and it reads .04. Closer to .05 if you flip it down to correct range. So I don't have any .03s. What I have is actually 30 volts higher, 630 volts, is a .033. So I don't think that's really going to hurt nothing. Let's go ahead and give him a test, make sure everything's good. It never hurts to check even new capacitors before you put them in a circuit. Sometimes they aren't exactly what they should be either. Occasionally you'll get a bad one. This one here is .03. It's exactly what we want. Not bad at all. So now we've got to wire him back in right here and up here. Here's a better look at the superior capacitor tester in some brighter light. Looks to me like all I've got to change, if I'd ever have to change resistor wise, is this big dog bone here. That's probably what, about a 3-watt resistor? I'm not sure how big that is. I can't tell by size, to be honest with you. And this little, probably half to 1-watt jobby right here. The rest of them are all more modern resistors. These are the only dog bones I see in here. The new capacitor's in. We soldered it where it belonged here. Now this is a non-polarized capacitor, so it does not have a plus or minus. You can go either way in the circuit. And I used some of the old lead dressing that was on the original capacitor, put back on the new one. But even though the old one came out and made a loop, it set in here this way underneath it here, and made a loop out and around and back, I still wanted to dress that in. That way you don't get any interference with anything else. This end didn't matter because it goes right to the end of the resistor right here, and the bulb that's in here for the leakage side of the tubes. Now, when it comes to cleaning, look at how grungy some of these controls are right here. Isn't that nasty? We'll take some alcohol and clean them up a little bit. That one and this one down here, they need some cleaning and some work. And then we'll spray some deoxit into some of these controls, because there's some rather funky stuff coming out of here. It's like, I'm not sure what it is. It's crusty looking crap. But we'll give them a good spray and see if that helps them out any. Well, they're much brighter and shinier than what they were. Look how dirty them nasty things were. Yuck. Well, the old alcohol saved the day again. So now we'll get out the deoxit and we'll spray them controls. Well, even though it is rather expensive, this is something I like to have in the shop because it's proved useful for many, many situations. And I forget how much this was. I bought this at Radio Shack. It was rather expensive. But what you have is a cleaner, which is the Deoxit D. This cleans all the oxidation off and the nasty crap and all the schmutz. And then you spray it with the Deoxit G Series Gold. And that's a prolonger. It kind of inhibits the corrosion and stuff from coming back. Well worth it. It works really well for shining up tube pins and sockets and cleaning out some of the nooks and crannies these old radios have. If a volume control gets kind of funky or something, you know, you could spray some in that and it'll quiet them right down. Well, I applied the Deoxit G Series Gold, worked the switches around a little bit, and boy did it ever loosen everything up. Them things are, you can feel every positive click in there now that these controls have, every detent. This does not need sprayed. This is like a rheostat here. It's self-contained. I'm not going to mess with it. Seems to work fairly well. The switches, hear that snap? You never had that before. Now it says to wait 1 minute, operate them, and then hit them again. And you wouldn't amazed at some of the crap that come out of these switches. It's absolutely nasty. It's like orange, brown looking crusty stuff. I'm not sure exactly what it is. Well, the superior tester is set back in its box. I haven't screwed the top down yet because I want to make sure everything's good. So we'll do a line adjustment and see what the line voltages is. So we need to set our filament to 117, 110 and put that in the high. We want to adjust the circuit selector to the line adjust, and we want to set our load to a maximum of 12. And the quality we want to set, quality leakage we want to set over to quality, and we'll start off high. Remember, this is the switch that wasn't working correctly, and power it on and see what we get. These switches are still kind of funky. It's going to take some time to work it back in, I think, but I don't think there's anything wrong with the switches. It's just and see right now the line adjust for 115 volts should come right up to there. We're a little low. We flip it over to low and we're a little bit on the plus side. So it looks like we're okay here. But yeah, some of these controls have got some funkiness still going on with them. Alright, well, let's grab a tube and see what it tests. And it looks like we are good to go. This is the 35W4 rectifier tube out of the Sylvania radio we've been working on. And it shows it's in the good range. About 80%. Now that reads a lot higher than what it did before I replaced that capacitor, so that capacitor was a little leaky or was going bad because before they would test just a hair over 60%. Okay, well that's good. Let's try out the rest of our tubes. Let's see here. Unplug him. Next we have a 50C5. We'll set our filament to high. Find it here in the tube supplement. 50C5. Voltage is 5, so actually we gotta go back to low, I'm sorry. Circuit selector on B. Load 3. And socket 3. And this is our output tube out of the Sylvania. Well, I know our 50C5 was good because the last time I had it in there, or I shouldn't say good, it was usable. It worked because we had audio output out of the radio, but here we're not even getting any filament lighting. Very odd. What do we have next here? This is a 12AT6. Let's see, 12AT6. That's even in here, yeah, right there. 12.6 volts. High. C, B, and D. 6, 12, and 12 in socket 3. 6. Plug him in all the way. 6, 12, and 12. And C, B, and D. Well, this one passes quality check. Just a little under 80%. Excellent. Let's test for leakage. No leakage. Alrighty. On to the next. This one here is a 12BA4 or 6, 12BA6. 12.6 C, 6 and 3. So plug him in up here and let's film it warm up. He don't look very healthy. About 32% down to replace. Well, he's kind of questionable. And lastly, I think this is a 12BE6 is what this one is. BE6. 6 and 3. Okay, exact same settings. And this is the tube that's very black inside. It doesn't look very healthy. None of these tubes except for the rectifier and the 12BA6 look very healthy. Okay. Leakage. No leakage. That's good. There it came up. Okay, this one's alright. So, looks like all of our tubes, short of the 50C5, look okay, and I don't know why that 50C5 is the way it is. That shouldn't be that way. So we get no filament at all. Nothing. Don't know. Looks like we might have a burnout filament on him. Well, there we got some leakage. 2 spots. Well, it doesn't look good at all now, does it?